Hey friends, so today we're gonna learn how to handle the nulls in SQL. So we're gonna start by understanding what are nulls, and then we're gonna learn the different null functions in SQL and their use cases to learn when to use them. So now let's start with the first question, what are nulls? So what are the nulls? Imagine you are filling out a form and there will be usually like fields that are required and another fields that are optional. So what usually happens? We leave those optional fields unanswered. So we don't provide any values and we leave it empty. And now once we are done filling out the form and we click on register, the data will be inserted into database tables. So now what can happen? The fields where you have provided answers and values can be filled inside the table, while the unanswered fields will have no value, and this is what we call in SQL a null. So in databases, a null means nothing, unknown. It is not equal to anything, so it is not equal to zero or empty string or blank space. A null is simply nothing. It tells us there is no value and it is missing. It's like saying, I don't know what this value is. So this is what a null means in SQL. Alright friends, so now we're gonna do a deep dive into special SQL functions on how to handle the nulls inside our data. Now in some scenarios we have nulls inside our tables and we would like to go and remove it and replace it with a new value, like for example 40. And in order to do that in SQL we have two functions, the first one called ISNULL and the second one called COALESCE. But now let's say that we have another scenario where we have a value inside our table like the 40 and we want to go and make it as a null. So now we are doing the exact opposite. We are replacing the value with a null. And for that we have the SQL function NULLIF. So as you can see with those two scenarios we are replacing stuff. So from null to a value or from value to a null. So they are really helpful in order to manipulate the data inside our databases. Now moving on to another scenario where we don't want to manipulate anything. We want just to check. So we don't want to replace or convert anything. We want just to check in our database whether we have a null value. And for that we have a function called isNull, but between the is and null there is like space. It is different than the first function. So if you apply isNull, you're gonna get a boolean, true or false. For this scenario you will get true. Or the second option, you can go and check whether the value is not null. So we can use is not null, and for this example you're gonna get false. So in the output we are getting a boolean, true or false. So those keywords are really amazing in order to check whether we have nulls inside our data. So this is the big picture of all functions that we have in SQL in order to handle the nulls. So now let's go and understand those functions one by one. So let's start with the first function, isNull. ISNULL gonna go and replace a null with a specific value. Now the syntax of the isNull is very simple. We're gonna use the keyword isNull and it accepts two arguments. First the value and then the second the replacement value. So let's have an example. We can go and use the isNull for the column called shipping address. So we are checking the nulls inside it, and if SQL encounters any null, it's gonna go and replace it with the value unknown. So this is gonna be like a default value for the nulls. So the first value is a column and the second value is like static, always gonna be the unknown if we find any nulls. Now of course in other scenarios we don't want to have it always like the unknown. We would like to use another column to help the first one. So let's have this scenario. So now with this syntax we are checking the values of the shipping address, and if we find any nulls it's gonna get the replacement from the billing address. So here in this example we have two columns. We don't have here any static value. We will get the values of the billing address only if the shipping address is null. So we are replacing the nulls using the help of other column, and in the first scenario we are replacing the nulls with a static value, the default value. So let's have a very simple example in order to learn how this works. So what we are doing, we are checking whether the value is null. If it's yes, then we're gonna go and get the value from the replacement, and if the value is not null, then show the value itself. So we have the following example. We are gonna check the values from the shipping address, and if there is nulls, then go replace it with the default value in A. So let's see how SQL gonna go and execute this very simple example. We have two orders. The first order we are checking the shipment address. is the value of this address is null? Well, no. We have a value A, so that's why SQL gonna go and return the same value. So in the output, we will get A. So if it's not null, it's gonna return the same value. So now SQL gonna move to the second order, and here we have the shipment address as a null. So what gonna happen here? If the value is null, then we're gonna get the replacement value. So what is the replacement value? Is the NA. So that's why in the output, we will not get a null, we will get the NA. So if you check the result, what happens? We're gonna get the addresses from the shipping address, but only if we have a null, we will get like a default value. It's very important to understand if you are using the default value, in the output, you will never get a null. Alright, so let's have another example for the second scenario where we are not using a default value, we are using a column. So we have a supportive column that's going to be checked. So in this scenario, we are saying is null shipping address and billing address. So we have two columns. And of course, the logic going to be the same, right? So we are checking only once. Let's see how SQL can execute this example. We have this time 3 orders and we have addresses from the shipments and as well from billing. So now SQL is always focusing on the shipping address since it is the first column. So we are not checking the billing address at all. So it starts with the first order. Is it null? Well, no, we have the value A. So we will get it as well in the output and SQL will not get anything from the billing address. So we will get A. So that's it for the first order. Now SQL gonna go to the second order and this time we're gonna have a null. So now in the rule we are saying if the shipping address is a null, go get the value from the billing address. So this time we're gonna go to the replacement, right? So we will get the value C in the output because the shipping address is a null. Now let's move to the third row. As you can see here, we have again a null. So SQL gonna go and get the value from the billing address. But here in this scenario, the billing address is as well a null. That's why we will get the value null in the output. So as you can see, having the replacements values from a column, there is no guarantee that there will be always a value. Like here in the third order, it is a null. That's why we will get null as well in the output. So if you think you are using ISNULL to replace all the nulls by having 2 columns, you might end up as well having a null in the output if the replacement having nulls. So if you want to make sure you don't get any nulls in the output, you have to go and use a static value. So this is how SQL executes the ISNULL. Alright, so what is COALESCE? COALESCE gonna go and return the first non-null value from a list. Alright, so now the syntax of the COALESCE is way better than the ISNULL. Here it accepts like a list of many values. So here, for example, we have value 1, 2, 3, you can add 4, 5, as much as you want. So we are creating here a list of values to be checked. So for example, we still can use it like the ISNULL where we have the shipping address where we replace the null with a static value, the unknown. Or as we learned, we can go and use 2 columns, shipping address and the billing address. So far it's like the same use cases as the ISNULL. But now of course the COALESCE is not only limited to 2, we can go and use 3. So we are saying go check the shipping address if it's null, then go check the billing address. If it's as well null, then use at the end the default value, the static one, the unknown. So as you can see, we can use more than 2 values with the COALESCE. Okay, so now let's understand the COALESCE and how this works. Now, the workflow is something similar to the ISNULL. So in this example, we have 2 columns, shipping address and the billing address. SQL gonna consider it as a list and it's gonna start checking from left to right. So it's gonna check the first value from the shipping address, whether it's null. If no, it's not null, then we're gonna go and get the value 1. So we will get the value from the shipping address. And if yes, it is null, then it's gonna go and get the value 2. So we're gonna get the value from the shipping address. Now we have the similar data. We have 3 orders. Let's see how SQL can execute it. So it's gonna start with the first row and it's gonna focus on the shipping address. So here the value is not null, so we have it as an A. So that's why we will get the value 1. So we will get the value from the shipping address and nothing else gonna be checked. Now moving on to the second row, this time the shipping address is null. So SQL gonna go and get the value from the second column and it's gonna be the C, right? So in the output, we will get C. Now to the last example, we have it as a null and SQL gonna go and get the value from the second column. And this time we're gonna get as well a null like the ISNULL function. So at the results, we are getting exactly the same result as ISNULL. So for this scenario, it doesn't matter whether you use ISNULL or COALESCE. So now, of course, we are still not happy with that because I don't want to see any nulls in the output, and I will still need to use the billing address instead of any static values. So I would like to have everything, the values from the billing address, and as well I would like to have at the end a default value so that I don't have any nulls in the output. So how are we gonna solve it? So now we can use the power of the COALESCE, where we can include multiple values in one function. So what we're gonna do, we're gonna have the shipping address first, then the billing address, and at the end we're gonna have the default value. So we have now a list of 3 values. And of course our workflow gonna be a little bit bigger. So again, here it's gonna start from the left to the right. So first it's gonna go and check the value 1. If it is null, then it's gonna go as well checking the value 2. And if the value 2 is as well a null, we will get the last value. It's gonna be the value 3. So now let's run the example again using the new COALESCE. So the first thing, we're gonna go and check the first value, which is the shipping address for the record number 1. So now as you can see, the value is not null. So we have here an A. So what's gonna happen? We're gonna get the value A as well in the output. So that means this one gonna be activated and we will not check anything else. So that means in the output, it's gonna be like this and the first value is returned and everything else will be ignored. So SQL will not check anything. So as you can see, we are returning the first non-null value. So now let's move to the second order. Now we're gonna check again the first value. Is it null? Well, yes, as you can see, we have here a null. So that means we're gonna go and activate this path over here on the right side. So now SQL will not go blindly putting anything from the billing address in the results. First, SQL has to check it. So SQL gonna check it whether it's null or not. SQL gonna go and return it as well in the output, and we have activated this path. So SQL is returning the value 2, which is the value from the billing address. So now let's move to the third order. SQL first gonna go and check the shipping address. Is it null? Well, yes, it is null. So that's why SQL gonna go and start checking the second value. So this time SQL will not return the billing address value since it's null. It's gonna go and return the third value. And what is the third value? It is our static value, the NA. So in the output, we're gonna get the NA, our default value. So with that, as you can see in the output, we will not get any nulls. We are using the default value and as well multiple columns. So if you check the output, it's always the first priority to check the values from the first column, the shipping address. If it's null, then the second priority gonna be the billing address. If it's null, then the last priority, it's going to be the default value. So as you can see, SQL is checking the values from left to right, and it stops immediately once it encounters the first not null value and return it in the results. So this is how the COALESCE works. Alright, so now let's have a quick summary about the differences between the COALESCE and ISNULL. So as we learned, the ISNULL is limited only to 2 values, where the COALESCE is amazing, where you can have a list of multiple values, which is a great advantage compared to the ISNULL. Now, if you are talking about the performance, the ISNULL is faster than the COALESCE. So if you want to optimize the performance of your query, then go with the ISNULL. Now, there is another problem with the ISNULL is that we have different keywords for different databases. So for Microsoft SQL Server, we use the ISNULL as we learned, but in Oracle they have different implementations. They use the NVL, and other databases like MySQL, you have IFNULL, and all those 3 functions are doing the same, but we have different implementations for different databases. But in the other hand, the COALESCE, it is available in all different databases. So here we have like an agreement or standards between the databases of using the COALESCE. So here again, this is a great advantage for the COALESCE, because if you are writing like scripts and someday you want to migrate from one database to another, if you are using the COALESCE, you don't have to change anything. But if you are using the ISNULL, then you have to go and adjust your queries and scripts with the correct functions. That's why I tend always to use the COALESCE and avoid using the ISNULL. Only if it's really necessary that I have really bad performance, I go and try the ISNULL, but I usually stick with the COALESCE. So that is my advice for you. Go with the COALESCE and stick with the standards. Now, the use cases of the COALESCE and the ISNULL are very similar, and we mainly use them in order to handle the null before doing any SQL task. For example, we can use them in order to handle the null before doing data aggregations. So let's understand what this means. Imagine that we have three sales. We have 15, 25, and a null. Now, if you go and use an aggregate functions like the average, what's gonna happen? SQL gonna calculate it like this: 15 plus 25 divided by 2, and the average is gonna be 20. So as you can see here, SQL is including only the two values, 15 and 25, and ignores totally the null value. So in the calculations, the null will not be included, because if SQL does that, the output gonna be as well null. So the nulls are totally ignored. Now the same thing can happen with the other aggregate functions like the sum, count if you are counting the sales, min and max. There is only one exception about the aggregate function count if you are using it with the star. SQL here is considering not the values, SQL gonna consider the rows. That's why SQL gonna go and include all those rows and find the output gonna be 3. Now in some scenarios, if your business understands the null as 0, then you can have a problem with the result of your analysis if you don't handle the nulls. So what do we have to do? We have to handle the null before doing the aggregations. So we have to go and replace a null with 0 using either the ISNULL or the COALESCE. So once you do that, the calculation gonna be changed for the average. So it's gonna be 15 plus 25 plus 0 divided by 3. And the output this time gonna be 13.3. So with that, you're gonna get more accurate results for the business if they understand nulls as 0. Alright, so now we have the following example. It says find the average scores for the customers. So let's go and solve it. We're gonna go and select the customer ID, the score from table customers. So let's go and execute it. So as you can see, we have 4 customers with a score, and the last one doesn't have any score, so we have it as a null. Let's go and calculate the average for the score, and I would like to have the window function in order to see the details as well. So this is average scores. So let's go and execute it. Now, of course, what is going on here? The 4 values gonna be added to each other's and divided by 4, and the null is totally ignored. Now, of course, the question is what the business understand with the null. If it is 0, then we have inaccurate results. So let's go and fix it. Now this time we're gonna say, okay, we're gonna have the average, but instead of score, we're gonna handle the nulls first. So we have to replace any nulls with 0. We can go and use the COALESCE or the ISNULL. So I will go with the COALESCE like this, and score. If you find any null, make it 0. So that's it. And as well, I will go with the window function. So average scores, let's call it 2. Now let's go and execute it. Now as you can see in the output, we got 500, and this is different than the previous average. And that's because we have replaced the null with 0. Let's just go and display it in order to understand it. So I will copy it and put it here. So let's call it score 2 and execute it. So now SQL is going to summarize all those values and divide it by 5. And that's why we are getting the 500. So if our business understands the null as a 0, this average gonna be more accurate after we handle the null. As you can see, in some scenarios, we have to handle the nulls before doing any data aggregations. Alright, moving on to the next use case for the COALESCE and ISNULL, we can use them in order to handle the nulls before doing any mathematical operations. So let's understand what this means using the plus operator. So if you do plus operator between two numbers like 1 plus 5, you are summarizing the values and you will get 6. And if you do the plus operator between string values like A plus B, so now what we are doing data concatenations, and the output gonna be AB. So now if you go and replace the 1 with a value like 0, so 0 plus 5, we will get 5. Nothing fancy about that. And for the strings, if you go and replace a value with an empty string, so there is 0 characters between the two quotes, plus the B, so in the output you will get only B. So it's fine and nothing is critical. But now we come to the problem if you use a null. If you replace the 1 with a null, in the output you will get a null, because you are saying, okay, 5 plus something that I don't know. So SQL says, okay, you are summarizing now a value with a no value. It is unknown, so I don't as well know what's gonna be the answer. That's why SQL gonna say it's gonna be null. SQL just don't know what is the answer. And the same thing can happen with anything else like the string. So if you are saying null plus B, and here SQL gonna say the same thing. the null is unknown and the answer gonna be as well unknown. So my friends, this is very critical in the analysis and working with data. So this means we have to handle the nulls before doing any mathematical operations, and this is not only for the plus operator, it's as well for the other operators like minus and so on. Alright, so now let's have the following task, and it says display the full name of the customers in a single field by merging their first and last names and add 10 bonus points for each customer's score. So let's go and solve it. We're gonna select first the basic informations. Let's get the customer ID. What do we need? The first name, the last name, and we need the scores. So that's it. From sales, customers, let's go and execute it. Now the first task is that we have to generate a new field called full name, where we have to go and merge or concatenate their first and last names. So let's go and do that. We need the first name plus, and then let's have a space between the first and last name, and then plus, let's have the last name as full name. So let's go and execute it. Now if you check the results for the first customer, it is working. So we have Joseph Goldenberg. The same thing for the second customer, but for the third customer we have here a problem. Customer doesn't have any last name, but she has a first name. So we have here a Mary. So the full name here is completely null, which is not correct. For this example, we have at least to show the first name Mary, even though that the last name is missing. So the result is not really accurate, and that's because we are doing the plus operator between a null and Mary. So that means we have to go and handle the nulls before doing any plus operator. So again, here we can go with the COALESCE or the ISNULL. So let's go and create a new field using the COALESCE. So it's gonna be the last name. And now we have to define a new value. If it's null, so we could have like something unknown, or we could have like an empty string. And we can do that using two quotes, and between them there is nothing. So we are using an empty string. So let's go and check the results. Last name 2. So let's go and execute it. Now we can see that the last name over here for Mary, it has an empty string and it is not anymore a null. So now SQL knows, okay, this is a string and there is no characters inside it. So with that, SQL knows more informations, and we can go and now concatenate those informations. So let's go and do that. We're gonna take the whole thing and replace the last name with the COALESCE. So let me just remove this last name over here and execute it. So now as you can see, things looks better. Now we have in the full name for Mary only the first name. And of course, if you don't like it like this, you would like to have another default value, you can go over here and say something like NA not available. So let's go and execute it. And with that, you can see immediately, there is here a missing last name, but it doesn't really look good. So I will just remove it and go with the empty string. We're gonna go and execute it. So with that, we have solved the first part of the task, where we have the full names and we are not missing any informations from the first name and the last name. Now let's go to the second part of the task, where we have to add 10 bonus points for each customer score. So we have to go and add a 10 for each score. So let's go and do it. I'm gonna put it at the end. So score plus 10, and let's give it the name score with bonus. So that's it. Let's go and execute it. So now in the output, you can see it's very easy. We have added a 10 for each score. So we have increased the score points for each customer. But now for the last customer, Anna, you can see over here, she doesn't have a value in the scores. And that's why SQL didn't go and add a 10. So we will get as well a null. And of course, this might not be fair that the last customer is not getting any point, even though that we have increased for all others. So that means we have to go and handle the null by replacing the null to a 0. And only after that, we're gonna add a plus to it. So let's go and do that. I'm gonna add a COALESCE. If it is null, then go and make it a 0. And afterward, go and add a 10 points. So let's go and execute it. So now as you can see at the result, everything now is fair, where we have a 10 bonus points for each customers, even if the customer doesn't have any values in the scores. Like here, Anna, she has like null, but still she is getting a 10 points. So here again, as you can see, if you don't handle the nulls correctly before doing the mathematical operations, you might get unexpected results. So be careful with the nulls and handle them correctly before adding anything. Okay, moving on to the next use case for the COALESCE and ISNULL, we can use them in order to handle the null before doing joins. This is a little bit advanced use case, but it's very important to understand it. So let's understand why this is important. Let's have, for example, two tables, table A and table B. And in some scenarios, we have to go and combine those two tables using the joins. And now in order to join two tables, we have to go and specify the keys between the table A and table B in order to join on it. So in this example, we have two keys in order to join the tables. Now here comes the special case. If those keys don't have any nulls inside it and all the data are filled, then your join can work perfectly and you will get the expected results. And now you might have a special case where there are nulls inside the keys. So there are missing values, and this is a big problem because in the output you will get unexpected results and some records will be totally missing. So in this scenario we have to handle the nulls inside the keys before doing the joins. Let's have a very simple example in order to understand this behavior. Alright, so now let's have this very simple example where we have two tables and we want to combine them. So in the first table we have a year, type, orders, and in the second table we have as well year, type, and we have sales. So now we would like to go and combine those two tables in order to have all informations in one result. Now we can go of course and use the inner join between the table 1 and table 2, and the keys for the joins here, as you can see, we have the year in both of the tables and as well the type. So we're gonna go and use both of those columns as a key for the join. So let's do it step by step how SQL can execute this. So we need the year, type as the results. So SQL gonna go and take those two columns to the results. And we need the orders and sales. So SQL can take as well the orders and the sales from the second table. So now let's start doing it row by row. So the first key gonna be those two columns. So we have 2024 and the type A. So now SQL gonna start searching for those two informations in the second table, and as you can see we have here a match, right? So the first row is as well matching. Since it's inner join, it's gonna present in the output only the matching rows from left and right. So in the output we're gonna get the whole row from the table 1 and we will get the sales from the table 2. Alright, so that's all for the first row. Now let's move to the second row over here. So what are the values of the keys? We have 2024 and a null. So now if you check the matches on the right side, you can see we have a match here, right? It is logical. So it's as well 2024 and a null. So everything is matching and we should get it as a result, right? SQL cannot go and use the equal operator in order to join tables. So even though that is logically it makes sense to have it at the output, but still SQL cannot go and compare the nulls. That's why this is a problem. For this combination, SQL will not find any matching. So we will not get any informations for the combination of 2024 and null. So for us, of course, in the business, this is missing informations and as well inaccurate results. So we're gonna miss this row and SQL gonna go and jump to the third row. So here what are the values of the key? We have 2025 and a B. Now SQL gonna go and search it in the second table and SQL gonna find a match over here. So in the outputs we're gonna get those values. The order is gonna be 50, the sales 300. Now SQL gonna go to the last row and we have here again the same problem. We have here 2025 and a null. And of course, if you check the data, you will say, yes, we have a matching over here, but SQL will ignore it. So we have exactly the same situation and we will not find it at the results. So at the output, we will get only two rows, even though that those two tables are like identicals if you compare the keys. So with that, we are losing data at the results and we are providing inaccurate results. So my friends, if you have nulls inside your keys, what can happen? You will lose records at the output. So here it's very important to handle the nulls inside the keys before doing the joins. Alright, so now in order to fix it, we're gonna go and use either the COALESCE or the ISNULL in the join. So as you can see, we are not using the type directly, we are handling it by replacing the null with an empty string. It doesn't matter which value you are using, the main thing is that you have a value and SQL can go and map it. So you could have it as empty string or a blank or any default value. But I usually go with the empty string since it's a little bit faster than having any other characters. So now what can happen is we're gonna go everywhere and replace those nulls with an empty string. So now we don't have any nulls inside our keys, and let's go and see what can happen. So we're gonna start with the first row. Again, here we have a matching from the right table and we're gonna see the whole records in the output. So we will get as well the sales as 100. And now SQL gonna go to the second row over here. So this time we don't have a null, we have 2024 and an empty string. So now SQL gonna go and search for a match, and SQL gonna find it over here. We have as well 2024 and an empty string. So now what can happen in the outputs? We're gonna get a 2024, but here we will get a null. So we will not get an empty string, we will get a null over here, and that's because we are handling the null only on the join. So as you can see, we have here the ISNULL type on the join, but we don't have it on the select. So on the select, the type gonna be like the original data, and the original data was a null. We are just handling the null in the joins just in order to let SQL understand how to map and match the data. So in this example, I'm not changing the values in the select, so that's why we will get the original value, but the orders, we will get it 40, and the sales gonna be 20. Now moving on to the third row, I think you already get it. So SQL gonna find a match, and the sales gonna be 300. Alright, now we're gonna move to the last one, and here we have the same scenario. So we have 2025 and an empty string, so it's not null anymore, and SQL gonna go and search for all those informations, and it's gonna find it over here. So SQL gonna take this field over here in the type in null, not an empty string, because in the select we didn't handle it. So the order gonna be 60, and the sales gonna be 200. So as you can see now, the result is complete. We successfully combined both of those tables in one big result using joins, but as well using the help of the ISNULL function in order to have a complete result and not miss any value. So my friends, be very careful. Check always the keys whether they have nulls or not, and if you find nulls, go immediately and handle it, so you don't lose any records in the results and you get accurate analysis. Alright, moving on to the next use case for the ISNULL, we can use it in order to handle the nulls before sorting the data. So imagine we have the following sales, 15, 25 and a null. Now if you go and sort the data by the sales ascending from the lowest to the highest, what can happen is SQL gonna show the nulls at the start, and that is not because the null is the lowest value, because null has no value, but SQL show it like this. It's gonna place it at the start, and then below it we're gonna have the lowest value, so it is the 15, and at the end we're gonna have the 25. Now if you are doing the exact opposite, where you are sorting the data from the highest to the lowest using descending, so what can happen is SQL gonna sort it like this. We're gonna have 25, then 15, and the last thing that's gonna appear in the list gonna be the null. So here SQL is showing the nulls at the end, and that is again not because nulls are the lowest value, it has no value, but SQL do it like this, show it at the end. So this is how SQL deals with the nulls if you are sorting the data. So in order to understand this use case, let's have the following task. So the task says sort the customers from the lowest to the highest scores with nulls appearing last. Alright, so let's solve it. This is gonna be a very interesting one. So we need the customer information, so let's go and select, and we need the customer ID and the scores from sales customers, and let's go and execute it. So we have a simple list of all customers and their scores, but now we have to go and sort the data from the lowest to the highest. So we're gonna go and use the order by clause, and we need the field score, and since it's lowest to the highest, that means we need to have the ascending, and in SQL it is a default, so we don't have to go and mention it. So let's go and execute it. So now as you can see in the results, it starts from the lowest to the highest, and the first part of our task is solved. But now of course we have an issue, right? Because we have a null, and as we learned, SQL gonna put it at the first place on the list, but the task says with nulls appearing last, so we really don't want to see the nulls at the start. We don't care about it, so we would like to have it at the end of the list. So that means we have to go and handle the nulls before sorting the data, and here we have two ways to do it. One way that is lazy, and the other one is more professional. So let me show you first the lazy way. We're gonna go and replace the null with a very big number. So for example, what we're gonna do, we're gonna go and use the COALESCE, and we're gonna say, okay, score, and then let's have a lot of number, so that we have a really big score. I just want to select it in order to see the results. So as you can see, it's a very big number here. So if you take this and replace the order by with the a new score. So that's it. Let's go and execute it. So now if you check the results, we have already solved the task. We have listed all the customers from the highest to the lowest, and the nulls are at the end. So now the question, why do we call this lazy or not professional? And that's because we are defining a static value. And of course, for this example, it is working, but we don't know later what's gonna happen. Maybe things change where in the scores we're gonna get a higher value than this, and then sorting the data will make no sense since the null gonna be like in between values. So who knows, your value might be a real value inside the data. Now let me show you the other way, which is more professional in order to solve this task where we don't play with luck at all. So let's go and do that. I'm just move this a little bit here. I'm gonna go and create a new logic where we're gonna say case when if the score is null, then what's gonna happen? We want the value 1. Otherwise, the value gonna be 0. So end. So we are just creating a flag with 0 and 1. If the score is null, then we're gonna get the flag of 1. If we have a value for the score, we will get 0. So let's have it like this, and I will just go and get rid of this COALESCE. So let's go and execute it. Now, if you check our new nice flag, you can see we have zeros everywhere where we have a value in the score. But only once we have a null, we will get the flag of 1. So now once we got this, what we're gonna do? We're gonna go and sort our data based on this flag and the score. Even though the task is not mentioning anything about the flag. But we are using it in order to force the nulls to be at the end of the result. Let me show you how we're gonna do that. So let me just remove all this. So first we want to sort the data by our new flag in order to make sure that the nulls at the end. So we're gonna have our flag, and then afterward we sort the data by the score. So let's go and have the score. So again, what we are doing, first sort the data by the flag in order to push the nulls at the end. And now once all those values are equal to each other's, what's gonna happen? SQL gonna go and sort the data by the score. So SQL gonna use the scores in order to sort the data, and both of them are ascending. Let's go and execute it. Now as you can see, we're gonna get exactly same results. The values from the lowest to the highest, and the nulls are at the end. And as you can see with the order by, we didn't use any static values or any big numbers. And of course, we don't need the flag at the select, so we can go and remove it. So let's execute it. And with that, we have solved the task. So as you can see, we can use those nice functions like the COALESCE or the ISNULL in order to handle the nulls before sorting your data. So what is the function NULLIF? NULLIF gonna go and compare two values, and it gonna returns a null if they are equal. Otherwise, if they are not equal, it gonna returns the first value. Okay, so now the syntax of the NULLIF, it accepts only two values, value 1 and value 2. So here again, of course, you can go and use a column with a static value like the unknown. So we are comparing the values between a column and a static value, or you can go and compare two columns, the shipping address and the billing address. So again, here it accepts only two values. We cannot have it like the COALESCE where we have a list of multiple values. Alright, so now let's understand exactly what do we mean with the NULLIF. So the workflow can be like this. SQL gonna go and check two values, the value 1 and the value 2, and if they are equal, then SQL gonna go and return a null. But if the two values are not equal, SQL gonna go and return the first value. So it is the one on the left side. So by checking the outcomes here, we will never have a scenario where we're gonna get the second value. That means the second value always used as a check. So we are checking against this value. So either we're gonna get the value 1 or a null. Let's have this very simple example. We are saying null if price, and we are checking whether it's equal to -1. So we are saying if the price is equal to -1, then go and replace it with a null. Because it is data quality issue that we have a price that is negative, it makes no sense for our business. And if it is -1, then it means for us a null. We don't know the price of this product. So we will correct it using the null if. Let's check this very simple example. We have two orders. So SQL is going to start with the first order and check the first value. So what is the first value? Is the price. So here we have a 90. SQL gonna go and check, is 90 equal to -1? Well, no. That means SQL gonna go and execute this path. So that means in the output, we will get the first value, which is 90. So in the output, we will get a 90. Now let's move to the second order. Here we have a -1. So SQL can check, is -1 here equal to the -1 that we have in the nullif? Well, yes. So that means SQL gonna go and execute this path where we were gonna get the null value in the output, and we're gonna get it like this. So now if you compare the result from nullif and the price, you can see we don't have anymore the -1. And as you can see now, we are doing exactly the opposite as COALESCE and ISNULL. We are replacing a real value with a null. Now moving on to the second example, and this is very interesting one in the analytics, where we can go and use two columns inside the nullif. So in this example, we are saying nullif original price and discount price. So SQL have to go and compare the prices between those two columns, and if they are equal, it should return a null. And now you might say, okay, in this example, why we are doing this? Well, we can use it in order to highlight or flag special cases inside our data. And the special case here is if the original price is equal to the discount price. And if those two prices are equals, that means we have an issue in our program or something like went wrong as we are inserting data. So let's see what's gonna happen. For the first row, we're gonna go and compare the 150 from the original price with the discount price. So they are not equal, right? So that means SQL gonna go and return the original price, the 150 in the output. So let's move to the second order. Here we have the original price 250 and as well the discount price is 250. So they are equal, and if they are equal, then we will get a null in the output. So as you can see again here, we are not getting any values from the discount, we are using it only for a check. So with that we have a quick flag, like using the nulls as flag in order to identify where we have equal values. So this is how the nullif works. Alright friends, here we have a very nice use case for the nullif, and that is preventing the error of dividing by 0. Let's see what this means. Okay, let's have the following task, and it says find the sales price for each order by dividing the sales by quantity. So let's go and solve it. This should be very easy. So we need the order ID, we need the sales and the quantity from sales orders. Let's go and execute it. So now we have 10 orders, those are the sales and the quantity. So now it's very easy to calculate the price. It's gonna be the sales divided by quantity, and we're gonna call it price. So let's go and execute it. Now as you can see, we got an error says divide by 0 error encountered. So that means somewhere we have a 0 for the quantity, and this is a problem. Let's go and check the data again. So I'm just gonna comment the whole thing and let's go and execute it. So now by checking the result, yes, we got for the order ID 10. Here we have quantity 0, so it will not work if you divide by 0, of course. So how we can solve it? We can use the magic of the nullif, where we're gonna go and replace the 0 with a null. So getting a null is way better than getting an error, right? So let's go and do that. I'm just gonna remove the comment, and here we're gonna say null if the quantity equal to the 0 value. So that's it. Let's go and execute it. Now, as you can see, it is working. And with that, we are making sure that we are not dividing by 0. And that's because we replace it with a null. And if you divide anything by a null, you will get a null. So if you check the result over here, the order 10, we got the price of null, which is correct. And for the all other values, everything is working because we have values and we didn't replace it with a null. That's why we have values for the price. And this is a very common use case for the nullif. We can use it in order to prevent dividing by 0. Alright, so what is null? It's gonna return true if the value is null. So it is checking the value. If it's null, it's gonna return true. Otherwise, it's gonna return false. Now, the exact opposite, if you go use the is not null. So if you use these keywords, it's gonna return true if the value is not null. Otherwise, if it is null, it's gonna go and return a false. Okay, so the syntax for that is very simple. It starts with a value or expression, and then after that, we're gonna have the keyword is space null. And the is not is exactly the same, so we have a value, then afterwards we have the is not null, so we have the not operator after that. And the is not is exactly the same, so we have a value, then we have the is not, the not operator, then the null. So it's very simple. Let's have an example. We are checking whether the values of the shipping address is null, so we can have it like this: shipping address is null, or we can check the opposite whether it's not null, so the shipping address is not null. It's very easy. Okay, so now let's understand how this works. We are checking the value. So if the value is null, then return a true. If it is not null, then we return a false. So as you can see, it never returns the value itself or any nulls. So we are getting a boolean of true and false. So we are creating like a boolean flag in order to assist us with the checks. So we have this very simple example, price is null, and we have those two rows. So we are checking whether the price is null. In the first order, it is not null, right? That's why we will get a false in the output. And the second order, the value is null, so it is correct. That's why we will get true. Now, of course, if we go and use the is not null, it's going to be exact opposite. So is the price not null? Well, yes, it's not null. That's why you will get a true over here. So now for the second check, it is null, right? So the output going to be false. We will get the exact opposite. So that's it. It's very simple how the is null and is not null works. Alright, one very obvious use case for is null and is not null is by searching for missing informations or searching for nulls. And maybe after that we can go and clean up our data by removing the nulls from our datasets. Let's have the following task, and it says identify the customers who has no scores. Alright, let's go and solve it. This is very simple. So let's start by selecting star from sales customers. So we need everything. Let's go and execute it. Now, as you can see, we have our 5 customers, but the task says we have to have all the customers who have no score. So that means the result should return only the last record, since the score of Anna is null. So let's go and have a where clause. So where, and now what do we need? We need the score. Then we don't use the equal, we use is null, like this. So that's it. Let's go and execute it. And with that, as you can see, it's very simple. We have filtered our data, and now we can see all the customers where the score is null. This is a very basic check to understand whether our data contains nulls. Alright, moving on to the next task, and it says show a list of all customers who have scores. So back to our example, this time we're going to do exactly the opposite. We want a list of all customers where we have a value in the scores. So what we're going to do, we're going to say where score is not null. So if you go and execute it, you can see we're going to get a clean list where all the customers have a score. And with that, we get rid of all nulls inside the score field. And maybe this is helpful in order to do further analysis. Alright friends, now we come to very interesting use case for the is null, and that is by introducing a new type of joins between tables that's gonna help us to find the unmatching rows between two tables. Let's have a quick recap about the joins in SQL in order to understand the new types. So basically we have two sets, or let's say two tables, the left and the right. And if you go and use an inner join, what we are doing here, we are finding only the matching rows between the left table and the right table. So at the result, we will get only the matching rows. Now we have another type of joins called left outer join. And if you use this type, at the result, you will get all the rows from the left table and as well only the matching rows from the right table. Now we have another type which is exactly the opposite, the right join. And here we're going to get all the rows from the right table and only the matching informations from the left table. And now to the last type that we learned, we have the full join, where we will get all the rows from the left and as well all the rows from the right. So we will not be missing anything. So those are the 4 basic joins that we have learned in SQL. But in SQL we have as well other types that are more advanced, but we don't have in SQL any keywords for that. So the first one called left anti-join. So what we are saying here, we need all the rows from the left table, but this time without the matching rows. So all the informations that are matching with the right table, we don't want to see it at the results. And as I said, we don't have here an extra keyword for this type of join, but in order to get this effect, we're going to go and combine the left join together with the is null. And with that, we're going to get all the data from the left side, but without anything that is matching the right side. And this we call it left anti-join. And we have another advanced type for the joins called the right anti-join. This is exactly the opposite. So we are saying all the rows from the right table without having any matching rows from the left table. So all the information on the right side that is not matching the left side. So again, here we don't have a keyword for that. We're gonna go and work with the right join plus an ISNULL. So with that, as you can see, we have two new types of joins added to our 4 basic joins. Now this might be confusing. Let's have the following task in order to understand it. Show a list of all details for customers who have not placed any orders. Alright, so let's see how we can create the effect of the left anti-join. So let's do it step by step. We need here 2 tables. We need the customers and as well the orders. So since we are focusing on the customers, the left table is gonna be the customers. So let's go and do that. So we're gonna go and say select star from sales customers. This is our first table, so we are using the alias of C. So let's go and execute it. Now, as you can see, we got the list of all customers, so with that we have all the details for our customers. But now we have to go and join it with the orders. So in order to do that, let's have a new line, left join, sales, orders, and let's have the alias O. And now we have to go and define the key for the join. So on, it's gonna be the customer ID equal the customer ID in the order table. So now if you go and execute it, now what we're gonna do, we're gonna go and show the order ID from the table orders. So order ID, just to see whether we have a match or not. So let's have it like this and execute it. Now let's go and check the results. As you can see, those 4 columns comes from the table customers and only the last column come from the orders. So now what is interesting is to check the order ID, whether we have nulls or not. So as you can see, for the customer 1, we have everything matching. For the customer 2 as well, we have orders. The 3 as well. For only the last one, customer ID 5, we have here a null. So that means SQL was not able to find any order for this customer. So again, what this means, we have only one customer, Anna, where she doesn't have any order. But all other customers, they did have an order, and that's because we have values from the right table. So once we have values, that means we have matching. But since here we have a null, that means we don't have any matching. So now since the left anti-join says we would like to have all the data from the left table without having any matching from the right table, so that means for this example, we would like to get only this customer, Anna. And this is exactly as well fulfilling our task. The task says list all details for customers who have not placed any order. All data from customers where we don't have matching from the orders. Now I think you already got it how to get this effect. We're gonna go and filter the data like the following. So we're gonna have the where clause, and now we need the column from the right table from the orders. So we're gonna go with the customer ID comes from the orders. So we're gonna say customer ID is null. And of course, you can go with the order ID as well. You're gonna get the same effect, but I would like always to use the key that we are using with the join. So let's go and execute it. And now, as you can see, we got the effect of the left anti-join. And with that, as you can see, we got the customer that we are aiming for. So here we have the data from the left side that is not matching the right side. So the customers who have not placed an order. And with that, we have solved the task. So as you can see, we have implemented the left anti-join by combining the left join together with the ISNULL. So this is the power of playing with the nulls in SQL. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.